Well, I recorded this video and then I just completely erased. I'm not going to start over, so I'll use the notes from when I made the first recording. In this problem, there are 18 values, so that means the median will be in the middle, which will be the average of the 9th and 10th. Therefore, the median is the average of those two values, which means the median is 10. To find quartile 1, those two values in the middle, split them down the middle and include that 10 when you find the median of the bottom half. Now that was 5. There were 9 values down there, so it was the 5th value, the one right in the middle. So quartile 1 is 5. And similarly, when you cut it in half, look at these 9 values, there's quartile 3. So our number line is labeled number of hours per week for PNCA students. Scale is evenly spaced. And quartile 1, median, and quartile 3 will always give us the box. And minimum and maximum will give us the whiskers. This box happens not to have 3 vertical lines, but just 2 because quartile 3 and the median are the same. That's it for the box plot. Let's take a look at number 10. What do mean and median have in common, and what's different about them? Well, they are both ways for describing center. They are both measures of a typical value in a data set. The biggest difference has to do with whether or not they are resistant to extreme values. And the mean is not. But the median is. In other words, if we look at that last data set of 18 values representing the number of hours PNCA students work per week, the mean is currently 9.98. If we change the largest number from 40 to 400, the mean would then change to almost 30. But the median would not change at all. The median would still be 10. Whether the extreme value was 40 or 400 makes no difference. The median is resistant to outliers in extreme values. The mean is not. The mean becomes skewed when extreme values are introduced. All right, what else? The cube problem, last one of the sheet. So remember, we have 1D scale factors, 2D, and 3D. And if the 1D scale factor is f, then squaring that will be the 2-dimensional scale factor, and cubing it will be the 3-dimensional scaling factor. By scaling factor, we mean the value you would multiply something in the smaller version to get the corresponding quantity in the larger version of that proportional item, in this case, a small cube and a big cube. So in this problem, the given information is 9 times as much paint. So that's to cover a surface. Surface is 2-dimensional, so 9 is the 2-dimensional scale factor. And so if that's f squared, the 1-dimensional scale factor will be just f. If f squared is 9, then f is equal to 3. 3 squared, and 3 cubed. Now we can answer the questions. C. How much more water could you fit in the large cube? Well, this is 3-dimensional space, so it's going to be 27 times as much water. In terms of tallness, that's a 1-dimensional quantity, so we have to use the 1-dimensional scale factor. The tall cube will be 3 times taller than the small cube. So if the small cube is 8, the large cube will be 24 centimeters.